We're talking about 1 to 2%. And there's no impact, zero impact on latency or bandwidth. And let me show you why. Let's say you had a system that had 6 CPUs, some amount of memory, and I/O. And I put a monitor on here. Then I can host VPARs. Now this VPAR, let's say, is running 11IV3. It's running Oracle. And I've tuned all the parameters here for doing batch processing. Okay, and let's say I have another VPAR, also running 11IV3, also running Oracle, and I've tuned it for OLTP. Okay? Now normally maybe I wanted to keep those separate. If I kept these separate, maybe I had to buy 2 5-way or 2 6-way systems. Now watch what I can do using something like Global Workload Manager to set up a rule like this. At night, batch is my #1 priority. Okay, so #1 at night. And he would get up to 5 processors here. You always have to have this 6th processor, 1 processor staying in the VPAR, because nobody has yet figured out how to run a virtual partition without a processor, or an OS without a processor. But during the day, I want this OLTP environment to be the #1 priority. So Global Workload Manager will automatically, as demand increases over here, move this over without resetting Oracle, without disrupting Oracle. And look at the cool thing here. Instead of having to buy 2 5-way machines, I bought 1 6-way machine, licensed it for Oracle, licensed it for HPUX, and I saved myself a significant amount of money in doing so. Now, I talked about latency and bandwidth. The reason why those aren't impacted is that the drivers and the ownership for I/O is up in the VPAR itself. So that's why it's a little further down on the away from flexibility, is more isolated than some of the other technologies I'm going to talk about in a moment. So everyone see this integration by design, because I took Global Workload Manager and I integrated it with VPARs. I could even integrate it with ICAP and be able to turn on and off processors automatically and insert them and delete them from this VPAR environment. So VPARs, shipping for a long time. We've got hundreds of customers running mission-critical environments with Oracle, with VPARs across the globe today. So, the next technology from HP, Integrity Virtual Machines. Came out in 2005. It's also software isolation. This one's multi-OS. This one, to think about it, is the most VMware-like of all of our technologies. So I'll make a note here. It's VMware-like. VMware doesn't run on Integrity machines, and Integrity Virtual Machines doesn't run on x86. So how does this differ? So again, I have a physical system. This time I've got 4 CPUs, memory, and I/O. Now, instead of calling it a monitor, we've got what's called a hypervisor layer. The hypervisor layer, I can now host guest OSs. So maybe this is an HPUX guest, and I instantiate it with 4 virtual CPUs. I have to start talking about virtual CPUs now, instead, and differentiate them from physical CPUs. Got another guest here that's running Windows. It's also got 4 CPUs, and last over here I've got a Linux guest that's also running 4 CPUs. With Global Workload Manager, I can dynamically allocate and deallocate percentages of processors. So this guy gets 40, maybe this guy gets 30%, 30%, and Unix will get 40%. And I can change those as my environment changes on the fly. So what's the difference here? Well, #1, there's a lot more performance hit. Instead of 1 to 2% like you had with the monitor, we're talking about 15 to 25%, maybe even more, depending upon how many guests you instantiate. And I'm going to emphasize this is really no different than VMware or any other hypervisor-based kind of virtualization partitioning tool like this. The more guests you have, the more energy it takes up. The way I like to think of it is this hypervisor layer is a liar, right? It lies to the guest OS about owning the physical resources. Yeah, you own that physical resource. Sure, that's yours. You have 100% of it. And just like in the real world, the more you lie, the more energy it takes up, and the higher this number becomes. I was actually talking to a customer out in Toronto, and they're like, Well, we put 20 guests onto a VMware image, and we noticed that there's some funny things starting to happen in I/O, and I'm like, I'm not sure anything's actually getting to I/O with that many. Well, what are you talking about? It's a super thin layer. I'm like, yeah, and you've made it fat with 20 guest OSs. It is super thin if I have only one guest on it, right? The more guests I add, the more work it has to do. So this is Integrity Virtual Machines. Some key aspects to this. I can take Service Guard and set it up on the physical hardware with the hypervisor, and now treat these guests as if they're application packages and fail them over. Well, so what? Well, look at this. I just took Windows and combined it with our mission-critical, best-in-class Service Guard clustering tool, and I can fail it over to other hardware. That's pretty cool. Because this is HPUX here in this hypervisor layer, if I had unallocated processors, I can turn on additional processors on the fly. Well, why is that important? Well, if I'm drawing 30% of 4 CPUs, and now I'm drawing 30% of 8 CPUs, I've effectively increased the amount of processing power available to this. So again, another cool aspect about all this being integrated by design. So that's Integrity Virtual Machines. I'll break. Is there any quick questions on virtual machines? Okay. There's two more I'm going to talk about. One is Virtuoso. Virtuoso, or PVC, Parallels Virtuoso Containers. This is something we brought out with Parallels, so they're a partner company, in 2008. And this is really OS isolation. And it's Windows and Linux on Integrity. So if you have customers that are looking to virtualize with Linux and Windows, and they're concerned about the performance hits here in an Integrity Virtual Machines, this is a little, actually this probably should sit over here. It's a little less flexible, but from a performance perspective, it yields higher performance out of it. And then analogous to it is the Secure Resource Partitions, SRP. This has been around since 2005, but it's based off of PRM, which has been around since like the dawn of time. And it is HPUX only. The advantage to both of these is it reduces the number of OS instances that you have to manage. What secure resource partitions are is in an open Unix system where everything can talk to everything else. You can cut down on that by creating containers or compartments that prevent that communication. And then you combine that with PRM and allow it only a significant amount of resources or an insignificant amount of resources, and you can control how much resources it gets. So, back to the slides. Another way of looking at this is this slide. What I've essentially done here is taken this slide and created with 4 or 5 flip charts this slide. Why do we bring all of this to market? Because if you look at our competitors, if you look at IBM, if you look at Sun, they have a much narrower range. And they're saying, look, you got a hammer, everything looks like a nail, right? All your problems can be solved by, by LPARs, or all your problems can be solved by Sun containers. What we have done with bringing all these solutions to market and having very mature, capable abilities, or whatever you want to say, but having this wide spectrum of ability here, is that we want to understand not only the technical problem that you're working on, but also the business environment that it sits in. Because none of your problems look the same from both a business environment perspective as well as a technical environment perspective. And then working with your customers' architects will best select the technology that fits that particular problem. That's why HP invests so heavily in partitioning, and that's why HP invests so heavily on making all of this work together. So lastly, I've kind of created here a summary slide that shows if you're in an HPT integrity position, HP itself has brought hard partitions and virtual partitions and integrity virtual machines and secure resource partitions and PRM, an exhaustive list of capabilities. We partner with companies like Red Hat and, as I mentioned earlier, Parallels. And we partner with Microsoft in order to bring other capabilities. And we've even added here where ProLiant is partnering to bring things like VMware and Citrix and Xen to the marketplace. So I'll open it up briefly for real quick questions, if there are any. No, I just stunned everybody. Okay, so to the audience out there, if you do have questions about this, please don't hesitate to contact me. I can be reached at paul.mantey, that's M-A-N-T-E-Y, @hp.com. Thank you.